Let's look into this compound inequalities with OR condition and to see how to write set builder notation for it, then graph it and write interval notation for it. Let's look into this compound inequality x less than minus 2 or x greater than or equal to 2. Set builder notation looks like this and we have to read it like set of all real numbers x such that x less than minus 2 or x greater than or equal to 2. Now let's see how to graph this inequality. Since x less than minus 2 not included into the solution, so let's draw open circle around minus 2. Now let's shade all the numbers less than minus 2 all the way up to minus infinity as solution. Now let's write this solution in interval notation. For that we have to write both the endpoints minus infinity and minus 2. Then add parentheses around it to indicate that minus infinity and minus 2 not part of the solution. Now let's graph second inequality x greater than or equal to 2. 2 included into the solution, so let's draw closed circle around 2 and now let's shade all the numbers greater than or equal to 2 all the way up to positive infinity as solution. Now let's write this solution in interval notation. For that, let's write the endpoints 2, infinity, then use square bracket around 2 to indicate that 2 is part of the solution, then use the parenthesis around infinity. Now let's write the solution set for this compound inequality in interval notation. Since this is OR compound inequality, we have to combine the solution. For combining both the solution, we have to use the union symbol. Now let's look at this compound inequality x less than or equal to minus 2 or x less than 2. The set builder notation looks like this. Now let's see how to graph this inequality. The first inequality x less than or equal to minus 2 included into the solution. So let's draw closed circle around it and now let's shade all the numbers less than or equal to minus 2 as the solution. Now let's write the solution in interval notation. For that we have to write both the endpoints, that is minus infinity and minus 2, and let's use the parenthesis around minus infinity and square bracket around minus 2 to indicate that minus 2 included into the solution. Now let's graph x less than 2. 2 not included into the solution, so let's draw open circle around 2 and shade all the numbers less than 2 all the way up to minus infinity as the solution. Now let's write this solution in the interval notation. For that, let's pick both the endpoints minus infinity and 2 and let's put a parenthesis around it. Now if you look at this graph, the solution for the first inequality included into the solution for the second inequality. Because of that, when you combine the solution, we can take the second inequality as the solution for this compound inequality. So let's make the second inequality solution as the solution for this compound inequality. So when we write it in the interval notation, let's write the interval notation for the second inequality as a solution for the compound inequality. Now let's look at this compound inequality x less than 2 or x greater than or equal to 1. Let's see how to write the set builder notation, which looks like this. And now let's see how to graph this inequality. X less than 2 not included into the solution. So let's draw open circle around 2 and now let's shade all the numbers less than 2 as the solution. Let's write this solution in the interval notation. For that, let's take the endpoints minus infinity and 2. Now let's put a parenthesis around it to indicate that minus infinity and 2 not included into the solution. Let's graph this inequality x greater than or equal to 1. 1 included into the solution. So let's draw closed circle around 1 and now let's shade all the numbers greater than or equal to 1 all the way up to positive infinity as the solution. Let's write the interval notation for it. For that, we have to pick both the endpoints 1, infinity. Since 1 included into the solution, so let's put a square bracket around it and let's put a parenthesis around infinity. If you combine the solution from both of these inequality, here we can see that all real numbers from minus infinity to positive infinity are the solution here. So let's shade all the numbers from minus infinity to positive infinity as the solution, and the interval notation become both the endpoints minus infinity and positive infinity surrounded by the parentheses.